This SD card stopped working and it contains precious photos of my customer's dog. And when we plug it into the computer, the SD card doesn't show up at all. It looks like there's a physical issue with the SD card, so let's see what we can do. First, we need to remove the protective layer that's on the back of the SD card. To do this, I draw a little square in this CAD software, which is connected to a laser machine. Then I line up the SD card with this red light and run the laser. The laser slowly strips away the coating, leaving behind the copper traces. See these little circles? These little circles are data lines which allow us to read the data. So how do we know what each little circle does? Luckily for this SD card, the schematics are already known. But if we didn't have the schematics, we would manually have to figure out what each circle does. To do this, we would use a logic analyzer to sniff out each line one by one. But since we already know the layout, let's continue. We'll solder the SD card to this adapter to read the data. First, let's tin the pads for all the data lines. Then we need to solder these wires one by one according to the schematic. SD cards are made up of three parts: the connector, which lets the computer talk to it, then a microcontroller which scrambles the data to make it more efficient. Then there's the NAND, which holds the data. When an SD card stops reading, usually the microcontroller has failed or the NAND has so many errors that the controller can no longer handle it. So what we're doing is bypassing the controller and reading the raw data directly from the NAND. Now that all the lines are connected, let's plug it into the PC3000 flash and see what's up. When we directly read the chip, we can visually see how the data looks. So let's dump the raw data and see if we can recover these pictures. Since we're bypassing the controller, all of the data is going to be a scrambled mess. Our job is to figure out how the controller scrambled the data and then reconstruct it. After correcting the ECC errors, we then need to unscramble the data through XOR elimination. Then we need to rebuild the page to match the original structure that the controller used. After this, we start to see our customers' pictures, but they're all corrupt. This is a good sign because it means we're on the right track. Lastly, we need to add an interleave which finally reconstructs the data. And boom, now when we scan the data, we can see that we recovered over 200 pictures. If you need something recovered, the link's in the bio. Peace.